Today I will discuss how to solve the linear equations using matrix. Now this method of finding the solutions of the linear equations using matrix is the simplest way to solve any non-homogeneous linear equations. Now all this system of linear equation can be written in this form. Here in the first matrix you can see all the coefficients of x1 are taken as the first column, all the coefficients of x2 are taken as the second column, all the coefficients of x3 are taken as the third column, and so on. So here this matrix is our matrix A. This matrix which contains all the variables is our x, and here this matrix which contains all the b's is b. So here this thing can be written as ax equals to b. Yes, you can multiply here with A inverse both sides. So what you will get, let's see here. As you know that A inverse A, this is I, and I into x is same as x. So here on the left side you will get x equals to A inverse B. So this is the basic thing that you have to use to solve the linear equations. So x, you can obtain x by finding the product of A inverse with B, and this is your A. First you have to find out the inverse of that and then multiply it with B, and you will get the values of all the variables. Now there can be three conditions. The system can have unique solutions, so that time you will say that system is consistent and independent. The second case is infinitely number of solutions. You will get many solutions of x of the variables. So this time also it is consistent, but in this case it is dependent. Third case is no solution. Sometimes your system of equation cannot have any solution. So this kind of equations are known as inconsistent. So how you will find out that whether the system will have a consistent, inconsistent solutions? So first step is to find out determinant of A. So here, so now there are the cases. In the first case, when A is not, determinant of A is not equals to 0, then it will have unique solution. And from where you will get the unique solution? That unique solution you will get from x equals to A inverse B. Find out adjoint of A dot B. So first you have to find out adjoint of A. It doesn't have any solution, so no solution exists for that system. And if adjoint of A and B is coming equals to 0, then the system will have many solutions. So now we will see the example. So here I have taken three equations in terms of x, y and z. Now the system can be written as, here system can be written as ax equals to b, and here you know your A will be how much? For A I have told earlier, all the coefficients of x will be your first column, that will be 2, 3, 2, 4, and the second column will be coefficients of y, and your third column will be coefficients of z. So this is your A, and here x will be how much? Your x will be the variables which are x, y and z, and your B will be the terms on the right side that are 8, 1 and 4. Now for finding the values of x, y, z, the first step is to we have to find out the determinant of A. So first we will find out the determinant of A. So let's see what is the determinant of A coming. So here we'll see the determinant of A will be, we can expand it along the first row, and then we, so after finding the determinant you can see it is coming minus 17. So now you know that minus 17 is not equals to 0. That means it is, the solution will be unique solution. So you can write, therefore A is non-singular. So if A is non-singular, then you can write this x will be equals to A inverse B. Okay. So now your next step is to obtain the A inverse. So now we will find out the A inverse. Now we will find out the adjoint of A. So for finding the adjoint of A, we'll find out the cofactors and we will take the transpose of the cofactors. Now first we will find out the C11 cofactor of the first one. So for doing this, 1 plus 1 for C11, 1 plus 1, the sum of these two is positive. So here the first one will be, you have to remove the first row and first column. So what elements you'll get? You'll get 1, minus 3 and 2. So you can write it like this. Okay, so for C12, 1 plus 2 is 3, negative, so it will be negative of, remove the first row and second column. So what elements you have here? 2, 4, minus 1 and 2. Okay, now you will find out the C13. Now sum of these two, 1 plus 3 is 4, that is even, so the third one will come positive. So first row and third column you will remove, so you will get 2, 1, 4, minus 3. Okay, now the same thing we will do for our C21 and C21 and C22, C23. So here we'll find out 2, 1, so sum of these two is negative, means odd, so you'll get negative. 1 plus 2 is 3, so you'll get negative. Now for this, remove the second row and first column, so you will get minus 2, 3, minus 3 and 2. Okay, now the next one, C22, 2 plus 2 is even, so it will be positive. Now you will remove the second row and second column, so you will get 3, 4 and 3, 2. The next one is your C23, 2 plus 3 is odd, so you will get negative. So here you have to remove the second row and third column, so you will get 3, 4 and minus 2, minus 3. The same way we will do it for 3, 1. 3, 1 is even, so positive. So 3, for 3, 1 you will remove that one, so you will get minus 2, 1. I think this one is clear, so I am writing now. The next one will be negative, third row and second column, so you will get 3, 2, 3, minus 1. And the last one, it will be positive, and it will be 3, 2, minus 2 and 1. So you will simplify that one, and the result will give you the adjoint. Now you can take the transpose also, so just we will take it later. So it will be 2, 2 minus 3 minus 1. Here it will be 4 plus 4, 8, but minus 8. Next one will be minus 6, minus 4, minus 10. Here this one will be minus 4 plus 9, 5, but here you have negative sign, so it will be minus 5. And this one will be 6 minus 12, minus 6. This one will be minus 9 plus 8, minus 1, but one negative here, so it will be plus 1. This one will be plus 2 minus 3 minus 1. Here this one will be minus 3 minus 6 minus 9, and 1 minus outside, so it will be plus 9. And here it will be 3 plus 4, 7. So this will be your, now this is the matrix of the cofactors. Now you have to find out the transpose of this. So transpose of this will give you minus 1, minus 8, minus 9, minus 5, minus 6 and 1. Here minus 1, 9 and 7. So this matrix is your adjoint of A. So now we got the adjoint. Now we will find out the A inverse. So her A inverse will be, so A inverse also, you know what is A inverse? 1 by determinant of A into adjoint of A. So all the values you have, so that will be equals to 1 by minus 17, and then adjoint you have this one. Now you know the x is given by this A inverse into B. So here we will write down the values of A inverse and B, and we will get the values of x. So here your x will be equals to, this is your adjoint, so 1 by minus 17 into 1 minus 1 minus 8 minus 10. They will get minus 7 minus 6 1 minus 1. So here we have the values. So here I have taken the value of A inverse and B. So now you have to find out the product of these two and you will get the values of x. So here I am keeping this negative 1 by 17 outside, and then I will just find out the product of this only. So what we will get, let's see. So here we will get minus 8 minus 5 into 1 minus 5 and minus 4, and the second row will be minus 64 minus 6 plus 36. The third row will be minus 80 plus 1 and 7 to the 28. Okay, so here this one will be 1 by minus 17, and now we will add all this. So it will be minus 17 first row, second row we will get, so here second row will be 34 and the third row will be minus 51, and now you can simply write this thing as 1 minus 2 and this one will be 3. So this all is your x, and now what is your x? Your x was